everyone. Welcome to New Lab. I'm Sydney Grushak, and I am the Senior Director of Advisory here in Brooklyn. And I lead a portfolio of projects with our corporate, government, and nonprofit partners, where we work to solve critical issues for those partners by identifying and applying cutting-edge technology by world-leading startups, while supporting these startups with resources and connections in the push towards commercialization. And one of our longest-running partnerships has been with the New York City Economic Development Corporation, or EDC, who's here today. Together, we have launched dozens of technologies and tested them out right here on the ground in New York City. And right now, we're working on the Resilient Energy Studio, where we are helping startups to navigate the regulatory pathways to get approved and deployed here in New York City. And energy storage is really critical to the future of a resilient grid that can withstand stress, adapt to change, and serve New York City's population in the face of unexpected disruptions. But while New York City strives to be a leader in the energy transition, it also has unique challenges, such as density, aging infrastructure, and complex regulations that make approval and deployment challenging. I'm joined today by Charles Conwell of Novell, Jesse Weiss from New York City EDC, and Keely Earhart from Strobe Power. And we're going to talk through some of these challenges, as well as opportunities ahead towards scaling storage in urban environments like New York City and beyond. So I'd like to start by asking each of our panelists to please introduce yourself, tell us about your organization and your work in energy storage. Start with Charles.
Hi, everyone. Thanks for coming today. My name is Charles Conwell. I'm the CEO of Novell. And at Novell, our goal is to utilize the 450 million square feet of the built world that's in New York City and beyond to transition buildings into intelligent grid interactive assets that can be monetized and improve the resiliency for the city.
And I'm Jesse Weiss. I work for the New York City Economic Development Corporation. We are a quasi-governmental agency that's really focused on growing businesses here in New York, expanding our job force. We really focus on tech, life sciences, and the green economy. I'm on our green economy team, and one of the programs I manage is the Resilient Energy Studio, which Charles and Keely and Sydney are a part of, really trying to help energy storage companies deploy their products here in New York, really helping them get through the regulatory barriers, working closely with the fire department and the Department of Buildings who regulate energy storage here in New York City.
Hi, my name's Keely Earhart, CEO and co-founder of Strobe Power. At Strobe, we're building America's modern power plant. So the modern power plant is distributed, it's reliable, it's located close to where electricity is actually consumed, and it's made up of a range of technologies, including a lot of energy storage. And when you think about what goes into actually building and operating a power plant, there are really two main elements. There is the control piece, so how do you actually dispatch those energy assets? And then there is the energy management piece. How do you actually decide what to do and when? So more of the optimization and decision-making logic. At Strobe, we tackle both of those pieces. We have a fully vertically integrated stack that does everything from project planning to deploying hardware appliances that actually control those energy assets, to operating a control room, through to actually selling electricity from those assets into energy markets.
Wonderful, thanks. And from each of your perspectives, would like to hear how you see energy storage evolving as a backbone for resilient cities. And let's start with Jesse.
I mean, right now in New York City, we have some energy deployment at the utility scale, but really none at the building scale. Batteries will be important for a number of reasons. One is complying with our signature decarbonization law, which is really trying to lower the emissions from our buildings. Batteries can help with that. Batteries can help reduce electricity charges for buildings. So I think more and more that we tap the huge real estate market we have here, monetize those batteries in ways that both save money for the landlord and reduce our overall emissions and provide resiliency to the grid as a benefit.
I think adding to what Jesse said, in the very near future, every building will be its own mini power plant. And I think energy storage is going to play a key role in that. It will soak up excess electricity from solar production. It can be used to deload lines, which, as we all know, in New York City, the lines are some of the most loaded in the country, and it can be used for resiliency purposes, so replacing or in addition to existing backup generators, really improving the resiliency of those buildings.
And I think it's really important to remember that, I think batteries kind of get lumped into one big category, and they all sort of, people imagine they all look the same. They really have different functions, and there's different designs for specific purposes. And the way we consume power is critical to understand when you're thinking about balancing the grid infrastructure. And so batteries can be utilized to bring in flexibility, additional capacity on the demand side, and that distributed nature creates a more reliable zero point of failure integrated system if operated and built well.
Great, thank you. And so I'm going to go back to Jesse now to talk about a little bit, this is a great future we're imagining, and we're really trying to push towards those. And EDC is leading the way in bringing together regulators and startups to facilitate battery storage commercialization in New York City through initiatives such as the Resilient Energy Studio. But what do battery original equipment manufacturers, or OEMs, need to do to get approved for deployment in New York City? And why are there so few building scale deployments that have happened so far?
So it's a bit of a complicated process. For any battery product that wants to be deployed in New York, you'll need to get approval from the fire department to even before you can get to a project. You need approval for the product itself. That's called a TM2 process from the fire department. Basically, you need to have a lot of your UL certifications, a few other kind of hazard mitigation assessments before you can even get approved for your product. Then, once your product's approved, then you can get down to the site-specific area. So there's a bottleneck, and there's not enough products on that list that are approved. And then even once you're approved, you have to go through another process to get the battery through their permitting process for the site-specific. I think for these smaller batteries for buildings, it could be a lot. Even if your battery's on their approved list, you have all these regulations just for the site-specific. So I think for some OEMs, they may not know about this process, and ones that do may not want to go through many months or years of a product approval when they're probably changing their products so rapidly that by the time they get approval, they're on to their next iteration. So the big players like Tesla, BYD, they're on the list, but some startups, it's hard for them to really go through that process. First going through all their UL certifications, and then going through a separate process for New York.
Great, and so we have some firsthand experience with that on the stage. Charles is creating a battery that has to go through that process, and Keely works with the batteries that have gone on that list. So I'd love to hear from both of you a little bit of project-specific challenges that you've faced. Let's do two each, that you've faced in New York City, and how these compare to deployments in other cities. Start with Charles.
I think one of the challenges is the lack of clarity of what actually needs to be done, right? So if you meet all of the the national and global regulation for safety, there's still this subjective element to the fire department of New York making a decision. But when you're thinking about deployments into real estate, speed, time is money. So being able to know how long it takes to get a process through a system, get a permit, get the installation done is really, really critical. And then the other thing that I think is really important in this process is that the customers have a real value driver, knowing that it's going to be accretive to their business, whether it's an occupier of space or a building owner that's supportive in that process as well.
Yeah, so at Strobe, our business model is really focused on unlocking a lot of the opportunities that were enabled through FERC 2222, which was an order that was released in 2020. New York's implementation of that was the DER participation model in April 2024. And what those orders say is they say that small-scale assets can participate directly in energy markets, but with the big caveat that they have to display the same capabilities that traditional utility-scale plants have. So everything through from operating a control room that communicates directly with every New York utility and NYSO, the wholesale market operator here, through to qualifying as a metering services entity that actually provides revenue-grade metering data, through to entirely new tariff structures designed explicitly for behind-the-meter battery storage that's participating. So the main one here would be the wholesale distribution service, which is designed around behind-the-meter assets that sell directly to NYSO. So for us, with our battery projects here in the city, we were the first one to enroll assets with Con Edison under the new WDS tariff. And there's a lot of uncertainty and complexity around that, how that tariff is actually structured. How do you design and install meters that can effectively track electricity that's used for behind-the-meter purposes versus electricity that's used to directly sell into the wholesale market? And so I think echoing what Charles said, there's just uncertainty, and that extends timelines. And for our customers, they're typically commercial industrial property owners, they're looking at multi-million-dollar investments in battery storage. They need to have certainty around the project economics associated with those efforts, and that requires a lot more clarity around some of these new structures. So I think that touches on both the regulatory and the financial side. A lot of those challenges are nationwide. I mean, the ability for these assets to participate directly in wholesale markets is a national priority. But certainly all the complexities of being in New York City, the underground buried lines, and the kind of physical space constraints that come from the fact that it's just a crowded city, and the setbacks and whatnot that are required for battery storage definitely compounds that complexity.
Thank you. And Charles, I'd like to get into that a little bit more with you. New York City has a lot less space than many other cities. Can't put batteries in courtyards as much or in garages because they just simply don't exist. So tell us a little bit more. You're currently pursuing the first indoor installation of a building scale energy storage system in New York City. What opportunities does this type of installation present, and in New York City specifically, and why is this so important?
So when we started Novell, one of the key, where we started was thinking about how we would redesign a grid today, knowing how we consume power. And I think if you were to do that, you would start at the point of consumption, knowing and understanding that every device has this variable load profile. And so flexibility and capacity becomes really, really important. But with storage, you're able to handle that load imbalance at that point of consumption and give predictability to the transmission and to the production, which is really, really critical as we go into the next phase of, deploying AI and robotics into the world that we live in, and we electrify everything. And the other part of the equation that was really critical when we were laying out our business model was that we're not going to tear down buildings and start from scratch. So you have issues like space constraint. You've got existing electrical distribution. You have different load profiles within buildings. And so I think it's easy to look at a 1 million square foot office building on Park Avenue and say, big building, big load. But the reality is that that is a big building filled with thousands of small loads. And when you identify the situation that way, you really want to bring, at least at the building level, this storage and intelligence that can understand how and when power is being used. How is a building's load determined based on occupancy or the day of the week or the weather? And when you learn that, you can really predict how that load profile looks and reshape that curve. And there's a lot of value in doing that for the building owners and the occupants. The largest part of the utility spend is that peak load curve. And by doing this, you're able to almost, Tom Steyer said this, but double the capacity of the grid, right? So we talk about how much more generation we need. You can double the grid capacity to 2 terawatts plus by creating flexibility at the point of consumption.
Thank you. And Keely, this speaks a little bit to your business model as well, and the economics of installing a system like that. How can emerging business models like aggregation, resilience as a service, or virtual power plants really change the economics of battery storage?
One thing that I'm really optimistic about is the fact that when we model projects in New York City, you're often looking at 2 to 3 year payback periods, which is incredibly rapid for infrastructure investments. And the reason you're able to get to such compelling project economics is because behind the meter battery systems have access to so many more value streams than traditional utility scale battery plants. If you picture a traditional utility scale battery plant, it's a bunch of containerized batteries all co-located in one centralized location, typically away from the actual demand centers where the electricity is serving. When you picture a distributed power plant, like what we're talking about here, what Charles is picturing with batteries that are actually deployed directly at buildings, then what you can do is you still can access all of those same wholesale market services that a utility plant can access. So you can sell energy, you can sell capacity, you can sell ancillary services. But on top of that, you're able to access behind the meter retail value streams. You can do things like demand charge avoidance, which for a commercial or industrial building will account for 30 to 50% of their overall bill. You can do things like help the local utility deload their line during peak hours, things that are represented by the demand response value stream here in Con Edison service territory and across the state. And you can do things like provide resiliency to those buildings. So instead of having to install a backup diesel generator, they can instead install a battery asset. So all of those things stack in a way that is really compelling for the deployment of these assets.
Great, thank you. And I'd like to go back to regulation a little bit and talk about how this really interacts with some of these economics and getting these new projects out into the world. So I'd love to hear from anyone. We can start with Jesse on kind of what are the key regulatory or policy hurdles that are standing in the way of wider adoption, and how should the industry and startups specifically engage with policymakers to try to alleviate some of those hurdles?
So a few years ago, the fire department created a regulatory structure to have batteries go through a permitting process to be deployed. And they actually set the rules of the road. Like Charles mentioned, there's probably improvement they need to make to the clarity, the speed. So I think there's kind of two challenges. One is making sure that the rules actually are clear, they're consistent. And then secondly, I'd say is operational capacity. You know, places like the fire department weren't teed up to start regulating batteries. 10 years ago, they probably didn't even, there was no batteries even in New York City. And so they don't have the staff, the resources they need to cover the demand for batteries today, and just imagine the demand for batteries in another 10 years from now. So teeing up these departments to actually regulate these things, do them safely. I think a lot of startups probably are scared of regulations, say we need no regulations, we just need to allow these things to be deployed. I think for something like this, you really do need some regulations, making sure that you don't cut off the industry early by having one emergency or one fire. And I would just recommend to any energy storage company, any hardware company, someone trying to do work in cities is don't be afraid of the regulations, try to engage with the regulatory body before you have your first project. I think these two companies are doing that, really building relationships, teaching them about your product, and active engagement before you even have that first or second project, so that way you can build on that relationship and educate the regulators as well, because this is new technology, especially for New York City. We don't have a lot of this deployed, so just engage early, often. Don't be afraid of working with government.
Great, thank you. And I think that you touched on something really important. As folks who work in innovation, we often get a little bit jaded that everyone's kind of on the same time frame and has the same embedded knowledge that we do. But often change is difficult, and there's existing infrastructure that needs to be updated, and a lot of that education that needs to be done to start the movement of regulation and updating that needs to happen to make these projects actually able to come to fruition. And I want to touch on Keely a little bit. Your current project is looking to install batteries at telecom sites, which is a notorious legacy industry that's hard to change and also grappled with reliability challenges. How can your project support similar legacy industries as they strive to become less vulnerable to economic, natural, and other shocks? And how do you kind of use that as an opportunity to educate and to bring them into kind of the future in innovation?
Yeah, I would say the economics for battery storage systems often speak for themselves, which is really beneficial when it comes to working with a variety of industries. When you look at critical industries, things like telecom sites, they often have regulatory requirements to have resiliency. Like they must have backup power of some source. Traditionally, that was covered by backup generators. But what you're increasingly seeing is a widespread acceptance that those generators need to be augmented by battery assets and often even replaced. And I think the more that we can do to show how that is kind of a financially prudent move on top of all of the clear kind of energy efficiency and clean energy benefits that come from installing more of these battery assets, the more we'll be able to bring some of these industries into the future. I think what's very interesting about something like a telco site is there are thousands across the state of New York, right? So they're in really interesting locations already. And we've already talked about what a premium real estate is in a city like New York. Being able to have access to a lot of those sites and install new assets at those sites gives us an extremely interesting way to build out a robust distributed plant that is able to meet the resiliency needs of the grid writ large and of those individual sites.
Great, thank you. And I think as Garrett kind of touched on in the last discussion, you know, energy is one of those industries where we've really crossed the threshold of, you know, it speaks for itself and it is cost effective, and it's not a decarbonization in the energy industry is not something that you need to do just out of the goodness of your heart or based on incentives at this point. Would love to hear from any of you kind of on other industries that offer lessons or analogies that storage can learn from as we try to bring this to scale and get it out into the world at large.
I think one of the things to think about as we, you know, continue to move forward with how our technology is built, the equipment we use in buildings, you know, as we advance our power electronics, more and more devices, lighting, communication, security becoming low voltage. And so even in existing infrastructure like backup generators have sometimes voltage issues in buildings where when they kick on, the surge is problematic. So batteries are really, really uniquely positioned to help serve those needs and control the load throughout those buildings and respond much more quickly. You know, an HVAC compressor and incandescent light bulbs don't react the same way that a laptop does and high-speed data centers. So it becomes really, really critical.
Yeah, go ahead, Jesse.
I have a very niche analogy, but really focus on the regulatory piece. So any batteries deployed will need to go through all of their UL certifications. And anytime they update their product, they're probably having to get some new certification, or if they're coming to New York City and they have a product that's approved and they update their product, they need to get another approval. And so thinking about the pharmaceutical industry, and I know very little about the pharmaceutical industry, but approvals for generic drugs, can we have approvals for batteries that are generic or using the same technology, same chemistry? And not every company needs to get approved as long as they're using a similar template as others. So I think about regulatory approvals for other industries that have big safety concerns. How do you speed things up once the technology is scaled and there's lots of different companies doing similar types of products?
Yeah, I think also with the regulation, for startups or battery companies or anybody dealing with fire departments, it's really important to just remember the perspective they're coming from, which is, you know, creating safe environments, one for the occupants, but also for the first responders themselves once the incident starts, right? So it's how do you control a battery fire? Battery fires are very difficult to put out. They burn very, very hot. They burn for a long time. And so I think understanding that perspective and taking that into consideration when you're designing your product and working with them on the education of why it's designed to solve those problems. Typically, the engineers, for any of you who are engineers, you know the risks and the pitfalls or how you would design this to get around a certain regulation, right? And some of those conversations, I think, can be really helpful to any regulatory authorities looking to create a pathway for approval. And you may even find that you help create those guidelines for safer infrastructure.
And maybe taking it in a little bit different direction and less focus on the regulatory, one of the kind of business models or frameworks that we talk about at Strobe that I find kind of interesting is the comparison to like an Airbnb, especially in the early days, where you have a lot of these assets that are sitting around. In Airbnb's case, it was underutilized homes, underutilized apartments. And what Airbnb was able to do was they were able to better utilize those assets, right, to more effectively utilize those assets. What's really interesting about a battery, you're not going to install a backup battery in the same way you have a backup generator that's just there on standby in the case of a grid outage event, and then it's going to flip on, right? That would be a full underutilization. You're not going to get economics that make sense if you try to do that. What you need to be able to do is you need to be able to take that battery, install it, and then utilize it 24/7 for a variety of different services. It's going to satisfy that resiliency use case, but it's also going to satisfy a range of other use cases. It can provide ancillary services to the market. It can provide local energy arbitrage for time of use energy rates, right? It can reduce those demand charges. And I think thinking about how we can better incentivize the installation of these small-scale systems through looking at comparisons to kind of other similar industries where you're looking at investments in areas where you have underutilized assets and you want to deploy more of those underutilized assets can be an interesting model to consider.
Thank you. And want to go back to Jesse just for a moment. So New York City has really become sort of a testing ground, or we're trying to make it that way, for in one of the world's densest real estate markets. How is the city paving the way, and what lessons might that offer to other urban centers as well?
I think I would go back to the piece about working closely with the regulators. I know lots of battery storage, energy storage companies that have deployed here, have close relationships, are constantly sharing information with FDNY, DOB, taking them out to their sites to see how things work. I think there's definitely room to improve the regulatory, and we can look towards California and Texas, who are deploying batteries at a much different scale than we are. But it is important because we are so dense. Thinking about kind of the worst case scenario, back to my original point, if we didn't have the regulations in place and then we have a bunch of batteries come in and they're not regulated, we could end the industry before it even takes off. So yes, the regulations need to make it easier, the processes need to be easier, the permitting process needs to be more consistent. But I think for other cities, really building that strong public-private relationship, partnership to really figure out how we scale, but safely.
Great. And I would add to that, I think it's really interesting, you mentioned other places where it's just easy to deploy these big batteries that can have a lot of capacity. But in New York City, you need to really think about diversity. And to Charles's point earlier, there are different applications where different types of batteries make sense, different chemistries, different sizes, and they fit different types of needs. And we have a few on the floor today, so definitely check it out. But would love to kind of wrap up by asking you all what's kind of one thing that you, whether from OEMs, regulators, utilities, or customers, that you think must happen in the next 1 to 2 years to really accelerate adoption of storage?
I think really modifying the approval process from a one-size-fits-all approach. I think that there should be, as Jesse mentioned, specific pathways for different types of storage products, and additionally, that includes use cases, the physical products themselves, and then the iterative nature of them as well. It should be if you've gone through the regulation, you've been approved. Subsequent new versions, I think it should have a faster track.
I've been talking a lot about regulation, so I'll close with something not regulation focused. I think in the next year, we need to educate asset owners, building owners, and lenders about what energy storage is and the business case for it. Maybe the most sophisticated building owners understand it, even though if they haven't deployed it yet. But a lot of buildings around New York City are not the most sophisticated, and they may have never heard of energy storage or don't really understand how it can help them. So I say education is a big thing over the next year.
One thing I'm optimistic about is that we have the market structures and regulatory frameworks to incentivize the deployment of small-scale battery storage in a big way. And so what I would ask of regulators is to really lean in to helping work through the growing pains of this new model, because I think this model can work and I think it can be really effective. And I think the biggest risk is that the city and the state of New York continues to invest in a patchwork of incentive programs that mask like the underlying complexity associated with really unlocking the full potential of these assets, and instead focuses on making sure that this model works and supporting the companies that are trying to kind of unlock the potential of these assets.
Thank you. Yeah, so we've heard today about the promise of energy storage and where we're going and the opportunities that exist across the world, but the reality that we really need far more of it across sizes, industries, and applications if we're going to build resilient cities. And New York is striving to lead, but it's also one of the toughest proving grounds. But what gives me hope is the different perspectives that we've heard and the fact that all these different sectors are leaning in, governments, startups innovating with new business models, and markets pushing for scale. But can't stay at the pilot stage. We need to move faster. So definitely encourage everyone in the audience, if you have an OEM, to get into the fire department approval process as soon as possible. For building owners to really inquire about potential of energy storage, and engineering firms to incorporate this into your designs as well. And without this technology being deployed here, you can't really truly compete at scale. So the future of a renewable and resilient grid will be written in cities like New York. And want to just thank our panelists, Jesse, Keely, and Charles, and to our audience for being a part of building that future. Thank you.